Hey everybody, welcome to another episode of the Elixir Mix, our number 3 episode. Today we have on our panel Justin Bean.
Hey there.
Josh Adams.
Hello.
I'm Eric Berry, and our special guest today is Chris Keathley. Hey Chris.
Hey, how's it going?
Good, how you doing?
I am not bad. It's like a beautiful 70 some odd degrees here in the great state of Tennessee, and I have been enjoying all the lovely weather for the remaining 3 weeks that we'll have it before it gets just miserably hot and humid. So yeah, enjoying some time outside while we can.
So is it true that the whiskey in Tennessee is better when you drink it there versus when you don't?
Yes. In short, yes. Yes, it is.
Cool. Why don't you tell us a little bit about yourself?
Yeah, sure. So I've been hanging around the Elixir community, I guess, now for, I don't know, some number of years. I start losing track at this point. I kind of lurked for a long time. And right after I think Elixir hit 1.0, I started trying to be a more active contributor. So I jumped in and started working on a couple different libraries that we needed or wanted at the time for the company I was working with at the time. So one of those things was Wallaby. It's a testing tool that drives browsers and it looked a lot more like Capybara back in the day. It looks a lot different now because there was a lot of things that I didn't like about that API when we really got into it. And so I've been maintaining that for a long time. And more recently, I've been working on a lot of distributed systems tooling as that's kind of become the focus of my work and the things that I do in a professional setting.
What are you doing with distributed systems right now?
So right now, the big project is I'm working on an implementation of Raft for the Elixir community, so we can all take advantage of some more consistent solutions to distributed systems problems.
Eventually.
And yeah, so that's the thing is like I kind of think that most people coming into Elixir want CP Semantics for their applications by and large, because that's the kind of semantics that they're used to dealing with in other languages or other runtimes. And so I'm really interested in seeing what it would look like to give people tools that are built into Elixir that support those semantics. There's already a ton of great tools out there that support AP Semantics, like React and Phoenix PubSub and all these kinds of things that utilize CRDTs and Gossip and whatever else. Or even LASP does the same thing. These are all AP solutions to problems, and they're all fantastic tools. But it seems to me like when I'm working with clients or I'm working with people, they often have problems and they want to attack them with consistent solutions. So I'm interested in providing tooling for that kind of stuff. So that's been my focus for a while now.
Awesome. Do you have like some vague hand-wavy kind of consistent solution focused project that I don't know would help people figure out what they want CP for explicitly?
So you mean like as like an example project or or like something that I've built and exists in the world?
I'm trying to, run the line between things that you've done for people that you can talk about and also, things that you find interesting. So,
sure. So I think the big thing that always comes up, and I actually don't even know if this is a good use case for this, and my hunch is that it's not, but the thing that always comes up is people want a global process registry that actually ensures one process one process for a given like term, meaning like an atom or a name or something. They want one process in their cluster, and they want only one process in their cluster. And the majority of solutions out there can't give you that guarantee because they're AP solutions. And they're AP solutions because that's really what Erlang tries to push you towards. I think anyway, it feels in a lot of ways that Erlang wants you to sort of adopt like eventual consistency, if you adopt any consistency model at all. So you kind of adopt like AP semantics because of that. That's not across the board true, but that's the majority of the solutions.
Yeah, that's what I see most often for sure. Like,
can you explain that? Can you explain AP semantics real quick for those of us who don't understand?
Sure, yeah. So, right, I guess I keep throwing around these terms like CP and AP and didn't actually define what they are at all. But yeah, so when you have a system and it's distributed, there's effectively three sort of axes, three different points on the triangle. And those points are consistent, meaning that writes aren't lost, and that the most, like a read will read the most recent data. And this is going to be kind of a hand wavy explanation of this. So, hopefully people don't, this is not with any sort of rigor. I'm going to get probably pieces of this wrong semantically. So just, bear with me a little bit. But you can be consistent. You can have availability, which means that your nodes are up and can service requests. And you have partition tolerance. The physical universe that we live in means that in order to have a system that is like distributed, you have to handle partition tolerance because node networks just get partitions. You just don't have perfect networks. You don't have, the speed of light is a thing, it turns out, and we just can't send data that quickly back and forth. And so we don't get to choose that one. And there's a very, very popular theorem called the CAP theorem, which is the most misused thing ever. And I'm even sort of embarrassed now to bring it up, but it's a good learning experience, I guess. But it basically says that you get to pick two things. You get to pick either to be CP, which is consistent and partition tolerant, or you get to be AP, which is available and partition tolerant. In a CP system, what that means is during a partition, and that's an important thing because a lot of people skip that step. They don't realize that you're making these trade-offs only when there's a partition in your cluster or in your network, so when two nodes can't talk to each other. If you have a consistent system, then what ends up happening is that if enough nodes stop talking to each other, you stop being able to service requests, even if that node is up. So the node could be alive and clients could be able to connect to it, but if it can't talk to some number of the other nodes, then it can't guarantee consistency anymore. It can't guarantee that all the nodes agree on a piece of data, and it has to stop servicing requests. So it effectively doesn't shut down, but it just defaults to like errors or something like that. Contrast that with an available system. The available system, it doesn't matter if the nodes are disconnected or not. It will continue to service requests even during a partition, but it makes no guarantees at all about the consistency of the data. So you could have data in one of these nodes. Someone could request that data, and you would return the data happily, and it could just be wrong at that point in time. You just don't know. Now, typically, what you do with AP systems is you tack on this extra bit at the end that when the partition heals and the nodes can talk to each other, they sync data across and then they reconcile all the differences. And this is what we refer to as eventual consistency, which means that eventually, all the nodes are there and none of the writes have been lost long term. And that's a good way around these problems of the real world, especially when you're dealing with really large clusters. This becomes a much more aggravated problem under really heavy load and really, really large clusters. You just, as you add more nodes, you just take in that many more partitions that could happen just mathematically, sort of statistically. And so you just have to learn to deal with that. So eventual consistency is a good way around that problem. Did that help define that pretty well?
Yes. Yes.
Or did it just make it worse? I can't tell.
For our listeners, it probably did. For me, my eyes are swimming a little bit, but that's okay. I get the gist, I believe.
Cool. So like I was saying, there's a bunch of really, really good solutions that are out there, and there's ongoing research that's being done in the Erlang Beam ecosystem for specifically around AP solutions. And LASP is sort of the really, really big one that a lot of people know about. And it's truly, truly brilliant work. And they're doing some really amazing things on the Beam. But I think their focus, while super important, is also not the focus of the people that I work with on a daily basis. Like, I don't know anybody who, runs on more than 5 nodes. Like that's just not a thing.
You do. You
what?
know me. You know me.
Okay.
But
Sure.
Yes.
Yeah, I think the majority of folks who are just like, I want to spit up my Phoenix app, or I'm just getting into Elixir, like they're coming from a place where, let's say you needed 15, Rails Heroku dynos or whatever, and now you can run on 1 or 2 Elixir nodes. Like that's not I don't want to like slag like Ruby and Rails, but like that's also not a mischaracterization of sort of where we're at right now in terms of like the performance gains that you're getting. So most people I work with just don't have like those like really, really, really large clusters.
Hey, Josh, what are you using more than 5 nodes for at this point?
We're doing some cluster. It's not about getting a lot of nodes for performance, but we are clustering stuff inside of kind of a VPN in locations to do kind of some shared data, so that they can, if one of the nodes goes down, things that it wanted to get out into the world can still get out into the world. So it's only around 10 nodes per kind of like micro cluster, probably. That's where it's gonna get to. It could go higher, but it's not going to break the 30s in each individual cluster.
Are you like encapsulating state inside of Gen servers or something in those nodes, or how's that?
We're at the very exploratory stages still, but yeah, the general idea is that we're going to be passing around stuff that we want to make sure, even if I never get back on the internet, makes it to the endpoint.
Right. Interesting.
The company I work for right now, we have a big warehouse, and we have little like kiosks all throughout the warehouse, and they're all connected. Some of them are connected via hard line to a network, but some of them are just on Wi-Fi. And there's all sorts of there's all sorts of problems with that, just because you're in this sort of warehouse environment. All kinds of stuff could be going wrong. You can get disconnected from flaky, crappy warehouse Wi-Fi. Then that network at the warehouse could get cut off, which has happened before. And so you can sometimes reach for solutions, and I think AP solutions are really good for this. You can reach for solutions where the coordination can take place after the fact. And as long as like one node stays up, but is like talk to all those other nodes at some point, it can eventually like get the data back out of the warehouse. Like it's just one node. As long as everything's kind of sharing information, just one node has to connect to the internet, and then all of a sudden all that data can be back out to a server again.
That's what Gossip is for.
Right.
It's very good for that. We have another situation where we actually want to coordinate, and then of course that's much harder. But yeah.
What did the kiosks do that you're working on?
So they do a whole host of things. The warehouse mostly holds clothes and does a bunch of processing on those clothes, like washing and those sorts of things. And so we have different kiosks to like take in articles of clothes from the warehouse door, get them over to other stations and tag them. They go through like a QA process and those sorts of things. So there's a whole bunch of different places in the warehouse that we use all that stuff for.
I've never made a state machine for clothes, but I'm imagining it like for the process of cleaning clothes. It's, fun may not be the right word, but probably.
It's involved. I think the other thing is that the real world fights against your state machine, your idealized state machine, at basically every turn, because just because of the nature of human beings and the nature of people who are tasked with the goal of getting their job done that day, and who need to like move about this warehouse and try to be as efficient as possible. And so I think you can oftentimes start to put rules around systems in a way that is not beneficial to them, just because it's easier for us as like developers to figure that out. But we've had situations where someone was trying to do something good. So for instance, like say that they're walking through the warehouse and they notice like a garment like fell off the rack and it's on the ground now. Well, now it needs to go back through cleaning and go back through QA, et cetera, et cetera. But that's not what our state machine says that it can do, right? That's not what it's supposed to happen. But because they picked it up and they wanted to like go the extra mile, they like took it back over to cleaning, and then they put it back through cleaning, and now you got to handle these edge cases. And I sort of just I don't know how much it's tough, because it's like, I don't know how much I believe in this idea that you can have an idealized state machine for any of this sort of like physical goods and manufacturing stuff. Yeah. Just because you can't control it that well. And the more you try to control it, the more you penalize people for just doing their jobs. And so I've been for a long time thinking about alternatives to that sort of thing in a way that's like a little more freeing, maybe based on rules or based on events. I'm not sure yet. There's like a bunch of ideas like have been bouncing around in my head, but yeah, it's a hard process to model when you have, not just bits and bytes, and you have the real world interacting with you.
Yeah. Meat doesn't adhere to your state machine.
Yeah.
That's weird. We'll get there one day. We'll program the meat, and then cyborgs will rule us. Anything. So what are the names of the projects surrounding your CP system?
So the big project I've been working on is a thing called the project name is literally just Raft, which I guess the Elixir community is still early enough that I managed to snag Raft. I'm pretty sure like FX Raft and Raft X were both taken, but I got Raft, so I just grabbed that. All of this kind of work, it's not just me; it's a handful of other people, and all this work is a part of an organization called Toniq. It's Toniq with a Q, so TONIC. I'm sure we can put that in show notes or something like that. But and the GitHub org is Toniq Systems, and all the projects are there. The big one, like I said, that I've been focused on is Raft. There's some other interesting things in there having to do with event sourcing and CQRS, a little bit of CQRS, but mostly around event sourcing and trying to solve some problems that we've had with other event sourcing solutions. And so that all that work is going on there. There's also a couple other little pieces that are that might be useful for people if they're working on distributed system stuff. We have an implementation of hybrid logical clocks, which is a way to have a combination of wall clock and logical time. So you don't give up wall clock time, but you're able to actually track causal relations of events. So you can get a partial causal ordering of different events. And we use that hybrid logical clock implementation for a couple other things that we're working on.
Well, that's fascinating. Now I have to look at it.
Does it help you do resolution of conflicts if there's like events coming in an async fashion? Can you talk a little bit about some cases where you've dealt with that in the past?
Yeah. So I tend to think. Let me figure out how to say this correctly. I've worked with a lot of. I, like a lot of people, are very taken with the idea of event sourcing, especially in the Elixir world, where it seems to match really well with a lot of the way that people think about these kinds of things. But I think there's also a lot of, I won't say issues, but there's a lot of holes in some of the current, solutions that are out there in the world. I think the majority of it, to me, almost not always, but predominantly stems around message ordering and getting good message ordering. So we actually, that's one of our projects. It's called Maestro, and it's an event store. Currently, it has an adapter, but it's really it's kind of like Ecto, like it has adapters, but really it's Postgres. And so Maestro uses Postgres behind the scenes, and we use a combination of hybrid logical clocks and monotonic counters, just increasing counters to track ordering of events. And we do it at the database level with constraints. And so what we can actually do then is enforce ordering of all the events in the system, because we actually, let's say you have a form that you want somebody to submit or something along those lines. What we'll actually do is pass you a hybrid logical clock and a counter. And so when you try to submit that form, the first thing we'll do is we'll just try to blindly write it into the log, which is a database table. And if there's a conflict at all, if the constraint throws, then we figure out what was wrong. We give you a new version of what the state is now according to the log, and we return you back your data. And because we have these snapshots and such, and because we have this guaranteed message ordering, we can actually say, hey, in the time it took you to get the form and input something and then submit it, someone else wrote over it. Now you need to resolve conflicts. And that's, in the case where we don't know what to do, where we want to give a user that option to resolve that on their own.
Right.
And this is as opposed to the traditional strategy of just whatever.
Right. Yeah. And I think a lot of them are just whatever, like, write it into and for certain operations that's fine. Like lots of people have figured out how to make that work. But I think in the same way that I think a lot of people end up wanting CP solutions to problems, I think a lot of people just really want that guaranteed ordering because it's easier to wrap your head around what happened, and it's easier to stop problems before you poison yourself. Because that's the danger of these sorts of systems. If you build systems in this way, you can just poison yourself. You can get bad data in there, and then it's done. The whole thing is done for. So enforcing ordering in that way is a really good way to solve an entire class of problems. and we just eliminate like an entire class of bugs. Now, that's not to say bugs can't happen, but there's this subset of them that are just sort of solved for you. So that's been the biggest emphasis on the way that we've been approaching the event store stuff.
Interesting. Yeah, I worked on a system a couple of years ago, which was heavily using CQRS as well. And we had a strong offline use case for our iOS application. So we had people do persisting commands into the database offline. And then when they come back online, we would just like throw all these things into a RabbitMQ, and then we run it through our CQRS platform. And we were looking into gossip, and some of this stuff probably would have been really helpful for what we were doing at the time.
Yeah, for sure. I think that's also where like the different timestamping and that kind of stuff happens, because it allows you to handle real bursty traffic,
right?
And then start to reconcile these things.
Yeah, my least favorite conversation with a client when I ran a consultancy was when they came to us and they said, "Hey, we've got this thing, and it's essentially a distributed system, and it's like 95% done, but there's some bugs." I was like, "Oh, right. What's your consistency model?" They're like, "Do what now?" And yeah, it turned out that what they had was useless. Because it was based around, like, it definitely required collaboration, and there definitely was no planning around that. So anyway, turns out that's one of those things you can't really bolt on.
Yeah, I've worked on two different, like, pretty, what's the right way to put it? Pretty dynamic, lots of people interacting with the same pieces of shared state sort of all over the place, from multiple different clients, lots of interconnectivity with users. And both systems just took sort of an ad hoc approach to like what they referred to lovingly as eliminating race conditions. And I'm using the finger quotes around that. And it was like, trying to like catch water in a sieve. Like you're left with a system where you're just constantly patching things, you're constantly adding like ad hoc concurrency rules or ad hoc locks or ad hoc whatever around your problems in order to try to eliminate all of them. And it's because these problems are really hard. This is some of the hardest stuff I've worked on in my career. And it's really, really, really challenging. And I don't know. It's one of those things that you have to, a little bit of knowledge can make you really dangerous, because like, you end up trying to like bite off more than you can chew. But also like without looking at these things holistically, it's really hard to come up with good solutions.
Yeah. I liken it to the NoSQL fad, which is like, we don't have a schema, but really what we mean is we didn't want to take the time to figure it out. It's, we don't have a consistency model, but really we just can't be bothered to think through all these hard problems. So anyway.
Yeah. Well, I think there is something to be said for like, I defined what CP and AP are at the beginning of this, but in all reality, most systems, those are binaries, which are useful to talk about in sort of scientific terms. But in reality, most real systems, they float somewhere in between those two things. And everything sort of lives on a spectrum, and you just tolerate some amount of failures, you tolerate some amount of inconsistencies, and you pick and choose those battles, because the fact is, like, you just, this isn't purely science, it's not purely production, it's something in the middle of those two things. So you have to make those choices that are meaningful for your business. So, if it is like, well, we're just going to like last write wins, or last write wins is whatever gets to the server last, and to hell with the rest of it, then, sometimes you can get away with that depending on what you're working on.
Yeah, it works really well for a whole category of use cases. It's just not really a scalable model.
It's not satisfying. Can we agree that it doesn't feel satisfying?
Yeah, I think so. But the worst part is when I see someone actually come to the realization that, like, the first time when they realize, wait a second, we're in undefined territory here, and I don't know what should happen. And like, yeah, you're going to go read papers for 3 years now. Sorry, bud.
That's effectively what happened to me. I was working on some of these things, and I was working on one of those apps, and I just went down this rabbit hole of trying to like learn more and more and more. And the more you know, it's a little bit self-fulfilling. I think Fred Aber in one of his talks talked about this. It's like, if you have a bunch of distributed systems engineer look at a problem and you go, I just need this one server with a database. And they're like, yes, but what if we put a Paxos on that? Like, I think that's a little bit self-fulfilling too, the deeper down this stuff you go. But some of it is depending on your business case. Like some of it can be really useful and some of it is crucial to your business. So it's fun. I mean, if you find this stuff interesting and fun, then it's a good escape. It's a good hobby to have.
We're weird people.
So I saw recently that not only saw, I'm actually a listener. You started up a brand new podcast. Can you tell us a little bit about that, the motivation behind it, and where people can find it?
Oh, yeah, sure. So some friends of mine, Amos and Anna and myself, we were hanging out at a conference and we were just talking about how fun it might be to start up a new podcast. And the format is pretty chill. It's really literally just us getting together and having a conversation every week. And we don't really structure it almost at all. We have very, very loose show notes or anything. Like we don't really go into it with anything prepped. And it's just us talking about stuff going on in the Elixir world. It's called Elixir Outlaws. It's at elixiroutlaws.com if anybody wants to check it out. Like I said, we just kind of try to keep it chill and we talk about stuff that's meaningful to us or problems that we're having or things that we're working on in the community or challenges we're facing or whatever it is that's kind of irking us that week.
Very, very cool. Yeah, when we were talking about doing the Elixir podcast, I mean, there was one that was going on for quite a while that was, if I'm right, it was yours, right, Josh?
Nope.
No, I'm wrong. The Elixir, there used to be a podcast that was an Elixir-based one. That went for quite a while, but then it ended, I believe, last year, and there hasn't been one since, not one that I've found. And then we were talking about launching one, and then you launched one like days before we recorded the first one. I'm like, this is awesome, because we need to have more people talking about this. Now, people like me who are very new to the programming world as far as Elixir goes, I'm a 20-year, Java / Rubyist. It's such a mind shift to go and to really start to appreciate what Elixir can offer that hasn't been offered in the past, and to have more podcasts and people talking about it, I think is very, very wonderful.
I totally agree. And I think it firmly solidifies what I've been hoping for a while, which is that the community is growing and having more voices out there in the world is a good thing. It's a great thing because it means that people are excited about it. And I think that excitement is what really helps us build community and helps bring new people into this stuff. And I'm kind of an early adopter just generally, but I don't know. I tried out Elixir and then I just decided to stick around for a while because it solved all these problems that I'd had in every other language or every other runtime that I'd ever worked in. And it's totally, kind of revolutionary.
But it's also really, really fun to solve problems the way it leads you to. Yeah.
So how do you find the time to work on all of this open source stuff when first off, not congratulations. Thank you for all of your contributions. Wallaby looks amazing.
It is,
and it seems like you've been doing this for a very long time, and having a huge impact on the community. How do you find time to do that and still do your day job?
That's a great question. I'm not sure that I'm not good at it, but I think a big part of it is there's two sides of it, and one is the support network that I think you have to have in order to kind of pursue these things. If you're going to pursue, if you're going to pursue things if you're going to any interest, doesn't matter if it's programming or whatever, if you're going to pursue any kind of hobby or any sort of passion, you have to have a support network and the ability to do that. And I'm incredibly fortunate that one, I have a great job where I get to work on Elixir all day. I have some amount of spare time to work on open source. The job I had before this, like same thing, like I was given time to work on talks and work on that sort of stuff. And so I've had great fortune in that. I've had amazing employers. I worked for Carbon 5 for many years, and then I worked most recently at Litop. And so, both of those companies were really good about that. But even in just sort of my home life, my wife is super supportive about these kinds of things and understands that, these are things that really fuel my, it's tough. I keep using the word passion. It is, to me, it is. I'm not saying I'm not going to make a claim about whether that's good or bad because there's a lot to be said about making your passion something that's pretty close to your job. But My wife also realizes and knows me well enough to know, like, I get really obsessed with this stuff, and she's amazing about being able to take care of, help take care of the kids and give me some time to work on this. And, and then I try to pay that back and give her tons of nights off, and I take care of the kids in the morning and that kind of stuff. Because you have to have a two-way street there. So that's a huge part of it, is just having a support network. And I think there's a second part, which is like a much more, personal thing, which is like, this is right, wrong, or indifferent. This is the thing that gets me really excited. I love working on this stuff. And I go through periods like anybody else where we're just tired. And I guess the colloquial term is, burnt out. But for the most part, I try to take pretty good breaks. I try to carve off pretty regimented amounts of time where I work on these things. And that helps keep me sane. And it's just, some people go out on Friday night and I stay inside and I read distributed systems papers and I work on open source, to each their own, I guess, in that. But that's kind of how I end up doing it.
That's amazing. I love how you pointed out the fact that oftentimes in open source and in community building and all this stuff, we talk about how important it is for the developer to contribute, but it's often unnoticed or unspoken, the families, especially the spouse's contribution of time. I gave a talk about 4 years ago at EmberConf, and literally my wife was taking care of everything for like 3 months while I prepared that stupid talk. It's their impact is huge. So I'm glad you pointed that out.
So on a related note, yes, my wife also enables that sort of thing, and I'm terrible about actively telling her that's appreciated. So I should probably do that more. But back to the code, I have a question on testing. Like, it seems like this is a very complicated sort of specifically the CP system would be very complicated to test. I bring this up because, hey, I'm building a test harness essentially for a similar thing, though not CP, and I'm curious how you go about it. For me, I have a thing that I'm working on that I hope to open source that is doing things with Kubernetes and deploying things and actually reaching in and fiddling with running nodes. But I'm curious how you do it.
So there's a couple of questions in there about just testing in general, but also testing in the specific case of, you want to exercise these faults, find these like bigger faults like in your distributed system. I'll say in general, number one, property testing. Property testing is easily the most important skill that I have been developing for the past year, I would say. It translates to basically every language. It'll make you think totally differently about how you test systems. And it's super humbling because you realize all the things that you get wrong. And frankly, I'm a big dummy and I need all the tools I can get to help me work through these problems. So if you're not familiar with property testing, the really, really, really fast rundown is you generate fake data. You use that fake data instead of, writing examples like assert that 2 + 2 = 4, or assert that 2 + 3 = 5. Instead of writing examples in those kinds of ways, you just generate the data, and then you put properties around them that are much more generic, or based on a state machine model, or based on sort of a more abstract concept. And
like when I square a number, the result is bigger.
Right? Yeah. Exactly. So you can do that, and like I said, you generate the data. And what will happen is your test runner or whatever tool you're using will generate a bunch of data and try that test as many times as you can for the kind of data that you've said to generate for it. So if I'm testing math, I might generate integers or those sorts of things. And it runs that a bunch of times until it finds either succeeds or it finds a fault. And if it finds a fault, then it starts to work backwards from that fault to do what they call shrinking. And it takes the output or the original input and tries to shrink it down to the simplest base case that it can. So what you're left with at the end is this hopefully very small set of either commands or a very small example that proves the error. And testing in this way is it's super hard when you first get started with it because it's really abstract and really, really weird. And it just makes you think totally differently about how you test software and how you build systems. But man, once you start to get a taste of it, I don't ever want to do anything else. Like, I don't want to go back to what I used to do, because it finds all kinds of just weird edge cases that you never would have thought to try on your own. So that's the in a big picture sense. I would say you start with property. If you've got a system that is complicated enough that you care enough about its guarantees, and to be clear, that's not every system. That, like, not every web app needs that. Not every to-do list needs you to property test it. But if you have a system that is like substantial enough, that is complex enough, that warrants that, then property testing is easily your best tool right now. In a more specific case about testing, something as complicated as like Raft, where you need to do coordination across multiple nodes and multiple processes, and you need to test faults within that. I still use property testing, but I layer tests together, is how I would kind of describe it. So you kind of start with stateless things, where I might have a stateless version of my model, a stateless version of my system that doesn't write to disk and doesn't send messages. And you prove that thing works according to your properties. And you can do that in a bunch of little ways. And these would be kind of similar to the way that you would do unit tests, right? You do a lot of unit tests and then do a fewer integration tests, and et cetera, whatever that pyramid thing is that I don't even really know that I believe in, but the pyramid. So you start with those sorts of, kind of smaller stateless properties, and then you begin to layer on more complicated things on top of that. And, you have some bigger properties that really exercise the full system with multiple nodes connecting. And you have, tests that really kill networks in between two nodes and see what happens, and then revive the network, and then take down the node, and then destroy the database underneath the node, just delete it off the file system and see what that node does when it recovers. And, you can kind of layer all that stuff.
My question was, operationally, how are you actually doing the testing of, say, splitting the network?
Right. So there's a couple ways that I've played around with. One is using Docker and using like Docker networks locally. And then you can just like sever and connections manually if you want to just like test stuff out like that. If you're trying to automate it, there's a couple really good tools to do that. The most well-known, the one that sort of, I would say, thrust this kind of thing into the forefront is Jepsen. Yeah. So you can totally use Jepsen for this kind of stuff. And it's easily, I don't know about easily. It's, as far as I can tell, it's easily the most robust, and easiest to work with. We've been setting up Jepsen tests for our Raft implementation, and it's pretty straightforward. I don't know Clojure, but I look at the parens and kind of figure it out. And I've been able to like work through the docs and figure it all out and all that kind of stuff. So that's a really good one. There's a handful of other tools that you can use just for, destroying your network if you want to do that. Comcast is one of them. That's not like a joke. Like the library is literally named Comcast.
It's a good name. I don't know if it's not a joke. It's just
I did. Yeah.
I assumed the library name was a joke, but yeah, I've seen it.
Yeah, totally. Comcast is a great one. And then the thing I've been working on is you can actually swap out the module that does distribution, that handles all the distribution, and when you connect multiple Beam nodes together. And if you look at how they do SSL, like if you look at the SSL module that's in there for Erlang distribution, it's the same way you can do it. You can do that. There's some more work that goes into that. You also have to sort of play nicely with EPMD and some other things, which if you're not familiar with what EPMD is the Erlang port mapper daemon. And it's a external C tool that gets started when you start the Beam, and it's part of how you connect nodes together. But so if you can what I've been working on is a way to swap all that stuff out using a different like Elixir OTP module and behavior, or application rather, and then control segments, or control like network partitions rather, via just Elixir stuff.
I'm super interested in this because literally this is a thing that I'm doing right now. Right now I'm doing it all in sort of Kubernetes.
And I think that's actually like a really reasonable way to do it. I actually think in all reality, you want all of this. Like you want, and that goes back to the layering thing. Like my goal with Raft is to have those like stateless properties. On top of that, you layer some system level properties that do things like disable nodes and disable networks and stuff like that. But you can just do it all from Elixir, and you can kind of control it all from Elixir and Erlang. And then you want the thing above that, which is, you know, a Jepsen or a Kubernetes or a Comcast or something along those lines, just because, you know, it allows you to handle all of this wide, you know, swath of problems that could go wrong. You know, you don't know what's going to happen when you actually get running Docker containers out there in the world, running on like a real, you know, control plane, and see what happens. Like that's a very, very valuable thing, and you want all of it. I think if what you're trying to do, again, if your thing that you're building warrants it. For me, I'm working on a thing that claims to be consistent, you know, and won't lose people's rights and won't like, you know, like throw people's data away and that kind of stuff. So for me, it's like, it feels imperative. I mean, it is imperative that I solve those problems and that I have those things. You know, not every application needs that, but when you need it, you need all of it.
Yeah, but wouldn't your database-esque thing be faster if it just didn't write to disk, Mongo?
Yeah, well, that's true. Well, it also like if you fiddle some of the config flags, it should also nuke the entire database and backups.
Yes,
I think is the appropriate response. Man, yeah. Mongo is so easy. You know, it's funny. Like the one time I used Mongo, I really liked it. Like, but it's so easy to make fun of. It's like making fun of JavaScript. It's just a meme now. Like it's part of the zeitgeist.
Don't make fun of JavaScript. Come on.
I didn't say anything. I'm sitting here saying, you know, I let go and let God. People like want to use languages and like let them go off and use languages. It's not appealing to me, but that doesn't mean it's not appealing to somebody. But now, it's too easy to, you know, to take shots, and you know, it's you get in with the crowd.
It's important to me to take at least one shot occasionally at Mongo specifically. It hurt me once.
never really quite gotten over it. Yeah. Mongo was the one that got away.
Yeah.
That's awesome.
He's got the tattoo on his arm. Actually, it just says Mongo. It's got a big heart, but now it's like crossed out, and then there's a Postgres underneath it, like with it's like kind of a little bit of a cover up.
Yes.
That was like literally the wall at my office. We had a Mongo sticker and crossed it out.
So I was at a conference one time and I met a dude who had worked at Mongo. And I was like, because you're there and you're thinking like, I don't know how to make small talk. I mean, so here's the thing is when I go up to make small talk, I don't even know anymore. I don't know what I'm doing. So I just go up to people and I'm like, so like, how much money do you make? Because I don't know how else to like break conversations anymore. So I went up to the Mongo guy and I was like, I should go say hi to him. You know, I don't know anybody here. And I was like, so yeah, that time that Mongo deleted somebody's database, and without missing a beat, dude was like, it was one time on one server with a crazy config, and he lost it. He was super upset.
I wanna find that guy and replicate your first line now.
I felt so bad. I was like, I was just a joke. I'm really sorry.
All right. So yeah. Anything else we should cover before we go on to picks?
So I was kind of curious, like, Eric, you were saying that, you know, you're sort of new to Elixir. I'd be curious to hear what some of your experiences have been and what made you like it? Like what, you know, I'm really interested in how we start to continue to build the community and bring new people in. So it's interesting to me to hear other use cases and other people's backgrounds and stories about why are you here? Why do you enjoy this language?
Yeah. Oh no, definitely. I'm happy to talk about that. So my interest has been there since the Jeff Grossenbach podcast or video, the Elixir intro video from years ago. And like I said, I've been programming Ruby for about 9 years. And in those 9 years, I've been able to I've really established myself as a decent mid-senior programmer that can build CRUD applications like nobody's business, right? Last year, I started a company, a project called Code Sponsor, which the whole purpose behind it was to be able to help fund open source through ethical advertising. And that's kind of why I asked you about why, you know, what drives you, gives you the motivation, and prevents you from burnout. But in that time, I was pushing Rails pretty heavily to the limits, and I realized how silly it was that I wasn't using a concurrent, a natively concurrent language to track these, millions upon millions of impressions per month that I was receiving. And so it kind of got me down the Elixir path. And when I joined my current company, which they acquired Code Sponsor, and we've since rebranded it to Code Fund, I made the choice to switch to Elixir solely because I knew it was the right tech. I didn't know how hard it would be. I didn't know what type of barrier to entry there would be, but I knew that it was the right tech. So I said, okay, I'm hanging up Ruby for now, and I'm going to just do this in Elixir. So I did, and I built a very terrible application. You can ask Justin, and Justin has since been hired, and he's come in and cleaned it up and made it right. But the fact is that the beauty of Elixir is that there's no magic. It seems there's very little magic, and the functional mindset that it really is going from an object-oriented programming language like Ruby to a functional language like Elixir is really, it messes with your head. But once you get past that point, it almost feels like there's no hidden information. There's no hidden data. You always know exactly where you're at. You can hit pause, take a look at what for example, in Phoenix, what your con objects contains, and you always know what's going in and what's going out. So the biggest appeal for me is not only the speed, but the lack of magic that there appears to be.
I love that. And I think it's interesting that you touch on magic, because it's something I've had conversations about with other people. And I totally grok like the emotion that you're talking about, right? Like that the thing that you get bit by, and you're like, how did that even happen? And it was this thing that probably was useful at one exact point in time, and then all of a sudden started getting in your way. It's interesting to me to talk about magic because magic tends to be a good thing. It's cool. It's like, oh, this is a thing that feels really good. And I actually think there's all kinds of magic in Elixir, which is the kind of magic that makes you feel like, oh wow, this just worked. And the thing that I always go back to is like supervision trees. Like you have these supervision trees, and that feels like that kind of magic to me. Of like when you have it, it feels so good. It tells you exactly how it works. For the most part, with a couple little edge cases about race conditions when things get started, like you basically understand how it works, and then it does it, and it feels so good when you see it, and it captures that same spirit to me of the first time I quickly built a Rails model, and then was like, oh, I have a database, and I have a blog post. I have a blog now or whatever.
Yeah.
But I think it's interesting how quickly that can turn on you, and there's something about like you need to. It's you're walking sort of the razor's edge of providing just enough to do exactly what somebody needs to do in a pretty super useful way without going too far. And I totally get what you're saying. That's cool.
I recently went on a trip and visited my brother, who has been programming in Elixir and Phoenix for 2.5 years, and he would not shut up about channels and OTP. And so I recently bought like the little handbook of OTP and Elixir. I can't remember. I'll link it, but I recently bought that book, and he said, look, everything that you've experienced so far is great, but you don't even know the power of what you're dealing with yet. So he said, you come back to me after you read this book and after you really see what the true power of the OTP is and the true power of using channels in your views and all that stuff. So that's what I'm really excited for. And hopefully, as this podcast moves along, we can actually see, I'm bringing a very newbie perspective to this group. And with that will probably come a lot of excitement where you guys will be all like, duh. Of course, we know that. So cool.
I love staying close to that because you get to remember like the excitement. And that was one of the things I really enjoyed about running a consultancy was like when we were training people up and they got a thing for the first time. And it was, hey, this is awesome. And I'm like, that is awesome. You're right. And I'd forgotten how awesome that is. But anyway, so yeah, I'm looking forward to those moments.
I showed someone Ets the other day. And it was awesome. And it was just, it was like a kid in a candy store. Like they just went crazy with it. They're like, what do you mean this is just built in? I can just store things and look how fast it is, et cetera. It was like, it was awesome.
Yeah, I felt that way when I saw the SSH module. I lost it. I was like, you're kidding me.
Did you give him any kind of warning with the Ets introduction, or
none whatsoever? I don't believe in that. No, set people up for all kinds of failure. It'll be fine. I think we talked about it a little bit and talked about, here's the different modes, here's why they matter, here's kind of how this gets supervised. Here's what the overhead looks like, and here's the trade-off you're going to make or whatever. But no, I mean, yeah, it's so much fun. I mean, still, I don't know. Like I follow my bliss on a lot of things. And if I'm not having fun, that's a big thing. It's like, I'll just walk away from it. That's like my one superpower is I'm pretty good at being able to ignore some cost fallacy and walk away when something's not fun. And the fact that I'm still in Elixir means I'm still having fun. And I think it's still a really great time because, we don't have best practices yet. People want them, but we don't have them quite yet. We're building them still. And that's exciting to me because it means we're trying out new things and we're going to figure all this stuff out together still.
I still want to build an application that makes heavy use of process dictionary just because I know it's a terrible idea. So.
All right. On that note, let's move to picks. All right. So why don't we move to picks? Justin, why don't you go ahead and give us a start there?
Okay. In the non-Elixir world, I'll pick Phantom Thread, which is the new Paul Thomas Anderson movie, and it has an amazing soundtrack by Johnny Greenwood that I've been listening to today. And my other pick is, I'll go with some of the changes that are going into Dialyzer this week, which is a type checking and an error code consistency library for Elixir Erlang. And my buddy Andrew Summers, give a shout out to Andrew Summers, who's introducing a bunch of changes to that to make the error messages more consistent and more readable. So that's mine.
That's awesome. I did not know that was coming.
Yeah, I think he's introducing like 31 new commits or something in this pull request that drastically improves the quality of Dialyzer.
Is that part of the Google Summer of Code stuff that was happening with Dialyzer?
I don't know the answer to that, unfortunately.
I saw that's one of the Google Summer of Code projects is to add some of the stuff that you're talking about. So I didn't know, but
yeah, my buddy Andrew is just somebody who contributes a lot to open source. He's got some commits in Elixir Core and Ecto and things, and so just like when things piss him off, he fixes them basically. So this strikes me as something that just pissed him off enough for him to.
I love those guys.
Yeah, me too.
That's awesome.
Great. How about you, Josh?
So I pretty much always don't do Elixir-focused things for picks, and I'm going to stick with that. The Elm Game Jam just wrapped up. And there are 5 games. I just popped a link in the show notes. But really fun stuff to go look at Elm code. Anyway, so there's 5 Elm-related things that you can go play with if you're so inclined.
Awesome. So I'll go next. I have 2 picks, and you've probably heard them both if you listen to the Ruby Rogues. The first one, of course, is my favorite show all time, which is Bob's Burgers. If you haven't seen that on Hulu, you got to watch it. It is the perfect mix. It's like if you put South Park, Family Guy, and The Simpsons into a blender and ran it, out comes Bob's Burgers, and it was absolutely fantastic. The second pick I have is called Metabase. Metabase is a product that I use. It's an open source application that you can run on any server that allows you to connect to your database, and it gives you full dashboard tools, full query tools. It's essentially a must-have for anybody who wants to get into your database without having to write interfaces for it. And the best part is, at least one of the best parts is that you can embed those dashboards into your application and securely pass data pass data from your app to the dashboard so that it will generate dashboards specifically for whatever user, whatever view you're wanting to view. So those are my two.
Yeah, I can echo that. Metabase is amazing.
All right, finally, Chris, let's hear your picks.
Cool. So I have a couple. The first is I just got done watching a documentary on Netflix called Wild Wild Country. And I had liked documentaries anyway, but I was completely just arrested by this. Like I could not stop watching it. So it's pretty great if you're into documentaries and such. And the others are a little bit more abstract, but I've recently picked up a new hammock and hammock stand. And in an effort to be more like Rich Hickey, I've been having a lot more like hammock time in my life. And I highly recommend that for anybody who needs a little bit of quiet and getting away from things and just thinking about problems a little bit more. Hammock is great for that. And I've been spending a lot of time outside just laying in a hammock thinking about different things. And in the same vein of being outside, my other pick I would recommend for people is start a garden. I have a pretty big sized garden in my yard and spend every morning out there, picking a couple weeds, making sure everything's watered, bringing in stuff. And it is just so satisfying to have something that's not tech related, walk out there without your phone, without Twitter and all that stuff and just, spend some time with some vegetables. If you don't have a backyard or anything, get a pot, like a big flower pot and grow some lavender or peppermint or something and just embrace that side of life for a little bit.
Awesome.
Yeah, that's great. Okay, Chris, where can people find you online, or how can they reach out to you if they need to?
Sure. So I'm at Chris Keathley on Twitter. My website, which I ostensibly write a blog at, although not very frequently, is keathley.io. Pretty much Keathley all around the Elixir community and on GitHub and in like Slack and IRC and whatever else. So you can always hit me up there if you want to chat about stuff. And I think that's about it.
And don't forget the elixiroutlaws.com.
Oh yeah. Go check out elixiroutlaws.com if you're in the mood for more podcasts. And I hope it's interesting to a couple people.
Absolutely. Well, thanks for joining us. This has been awesome. And we'll wrap this up. Thank you and have a good day.
Bandwidth for this segment is provided by CacheFly, the world's fastest CDN. Deliver your content fast with CacheFly. Visit CACHEFLY.com to learn more.